Hey sixth graders, this is lesson 8-7. We are talking about data today and how it can vary. So we're going to be looking at something called a range, which is the high point and the low point of a set of data. And then we're going to be looking at something called quartiles, and we will get to that in a little bit. So let's get started. Our first part of our lesson today is fairly simple. Basically, your range, it tells us right here, you can calculate the range of a set of numbers by subtracting the least number from the greatest number in the set. So basically, you take your highest point and then you subtract your lowest point, and then that answer is your range. So in this case, it says Jayla and Sophie are members of a 6th grade basketball team. The dot plots below show the number of points scored by each player during the first 10 games of the season. So Jayla, you can see she played 10 games, and here's how many points she scored at each game. And here's Sophie. She played 10 games, and here's how many points she scored per game. So the range, like we said before, is a single number, and it summarizes the variability of a set of data. What that means is the range tells you how much do your data points vary. How are they different? Are they all clustered together and most of your data points are the same or close to the same? Or is your data more spread out and you're likely to have huge differences in your data? That's what it means by variability. Are your data points mostly the same, or are they pretty different from one another? You can calculate the range of a set of numbers by subtracting the least number from the greatest number in a set. So we're going to go ahead and find the range for Jayla and Sophie. So Jayla, the most she scored was 6, so that's the high range. And the least she scored was 2. So 6 minus 2 is 4. Her range of scoring points is 4. For Sophie, her high number was 8. We can see that on her line plot right here. And her low point was 0. And so, I almost did 8 again. was 0. So 8 minus 0 equals 8. So Sophie's range was 8. So then we're going to go ahead and do something that we already know. We already know how to find the mean and the median. And so we're going to calculate that as well for Jayla and Sophie. So for Jayla, to find the mean and the median, it's going to be more simple than for Sophie, because I remember from our last lesson that if you have a line plot of your data and you notice there's a line of symmetry, which I do, it's right here, and both sides of my data look identical on both sides of that line of symmetry, then your line of symmetry is your mean or your average, and it's also your median, your middle number. For Sophie, we're going to have to work a little bit harder. To find the mean or the average for Sophie, I'm going to add up all of her data points and then divide that sum by how many data points there were. So for Sophie's mean, here's my work for Sophie. Her mean is going to be 0 plus 0, because I have 2 zeros, plus 1, plus 3, plus 4, plus 5, and then there's 2 6s, and then a 7 and an 8. And so I need to add all those together. Let's see, I have 6 plus 8 will give me 14. 7 more gives me 21. 6 more gives me 27. 5 more gives me 32. 4 more, 36. 3 more, 39, and 1 more gives me 40. So the total of all Sophie's points was 40, but if we want to find the mean, we need to take that sum of 40 and divide it by 10, because when you divide by 10, that's because there's 10 data points. She had 10 different circles or 10 different games, and 40 divided by 10 is 4. So Sophie's mean is 4, which means that Sophie and Jayla had the same mean. They had the same average for their points in the game. They both scored on average 4 points per game. Now for the median, her middle, we need to find what is the middle of all of these. Now since there's 10 data points, I'm thinking that we're going to have to go halfway in between the 5th and the 6th data point, because 5 is the halfway number of 10. And since I have 1, 2, 3, 4, 5 data points right here, 1, 2, 3, 4, 5 data points right here, I need to find what's in the very middle of 4 and 5. For my median is going to be 4.5. So for my middle point, or my median, Sophie has 4.5. Now, it says on number 3, suppose you calculated the mean and the median for each of the other players on your team. Would your answers be the same as the mean and median for Jayla and Sophie, or would your answers be different? Well, of course they would be different. Every player is unique, right? You're not going to have the same set of data for every person on your team, because not every person on your team is going to score the exact same amount of points each game. So the data would be different. Every player is unique. Then on number 4, it says all 3 measures, the mean, the median, and the range, they describe the data in some way. But what does the range tell you about the data? So we know that for the mean and the median, these are their scores. They're very similar. They're almost, for both girls, almost identical, okay? But the range is hugely different. The range for Jayla is 4, and the range for Sophie is 8. And so what does the range tell you? Okay, what this tells me is that idea of variability. There is a smaller variability for Jayla, which means Jayla is more likely to score her average, which is her mean, I guess I should call it the mean, of 4 points per game. Because her range is smaller. Now, if you look at that data, that makes sense. If you say that they both have an average or a mean of 4, that's true. But look at Sophie. Do you think she's likely to score 4 points again? Maybe. I mean, that's her average, but her points are all over the place. Sometimes she scores hardly any. Sometimes she scores medium. Sometimes she scores a lot. She's all over the place. She has lots of variability. She has a high range. Compared to Jayla, her points are a lot more consistent. It's not perfect. She doesn't score 4 every single time, but her range is only 4, whereas Sophie's is 8. And so because her range has numbers closer together, she's more likely to get that average again. All right, next page. A set of numerical data is shown below. The median is the mean or the average of the 2 middle numbers, okay? And we already knew that because we know that the median is the middle number. And in this set of data, since it's in order and it's an even number, there is no middle number. So we know that the median from our last lesson is the average of your 2 middle numbers, which in this case, the very middle of 6 and 7 is 6.5. That's nothing new. But on number 5, it says, into how many equal parts does the median divide the data? So here's our median right here at this line. How many equal parts does that data have? There's a left side and a right side. There's 2 equal parts. So there's 5 data points on the left and 5 data points on the right. So now we're going to talk about something new called quartiles. And we're going to learn that there's a first quartile and a third quartile. There is not a second quartile, okay? That's called the median. They don't really call it the second quartile, but if you're wondering what happened to the second one, it's because the second point in your data is your median. You'll see that right here on this example. You have your first quartile, your median is kind of your second one, and then your third quartile. So let's talk about what it is. Quartiles are the values of the points that separate a set of data into 4 equal parts. The first quartile separates the lower half of the data into 2 equal parts. The third quartile separates the upper half of the data into 2 equal parts. So I'm going to make this a little bit simpler with a picture. We're talking about this. If you're thinking of fractions, the halfway point is the median right here. Median, right? And then they're saying if you wanted to turn this instead of halves, if you wanted to turn it into fourths, because quartiles has that idea of being a quarter or 1/4. fourth, right? So if you want to make this quarters, how would you do that? Well, you could split it horizontally across the middle, but if you wanted to have 4 vertical lines, or 4 vertical sections, I should say, this line right here would separate it into 2 equal parts, which is what they said. The first quartile, I'm just going to put first Q for quartile, it separates the lower half of the data into 2 equal parts, and the third quartile, right here, that little line right there, separates the upper half of the data into 2 equal parts. So what we're talking about with quartiles is this line right here and this line right here. The median we know is the line in the middle, but the first quartile is the line that separates the bottom half of the data into 2 equal parts, and the third quartile separates the right half of the data into 2 equal parts. All right. So look below at the numbers to the left of the median. So if the median is right here, we're looking at everything in blue, it says the first quartile is the mean, or the average, of the 2 middle numbers, okay? So we have 6 data pieces on the left. Now, because there is an even number here, there's no median, okay? If there was an odd number of data points right here, we could just circle the one in the middle, and that would be our first quartile. But there is not one in the middle, so instead we have to find the middle point of 3 and 4, which is what? What's the middle point of 3 and 4? It's right there at 3.5. Okay. Into how many equal parts does the first quartile divide the data to the left of the median? So it's saying that right here we've got the median, the first quartile is this green line. So it's saying how many equal parts does the first quartile divide this section into? 2 equal parts. Okay, so 2 equal parts is what this divided it into. And what number is that? It's 3.5, which we said right here. So now we're going to do the other half and do the right of the median instead of the left of the median. So now we're looking at these blue numbers, because our median is right here. We already found our first quartile. Now we're going to identify our third quartile. The third quartile is the mean, or the average, of the 2 middle numbers. Or if you have a middle number, it's just your middle number. But it's always finding the median, which is your middle number. Now, since we don't have a middle number, instead we find the average of those 2 middle numbers, or the mean, which is, what's the mean of 9 and 10? Well, it's 9.5. You can tell that 9.5 is right in the middle of 9 and 10. But if you did the math, 9 plus 10 is 19. And if you find the mean, you have to divide it by 2 because there's 2 data points, and 19 divided by 2 is 9.5. So now it's asking us a similar question to up here on number 6. How many equal parts does the third quartile divide the data to the right of the median? So this data right here, how many equal parts? 2 equal parts. And what number represents the third quartile? We already answered that, 9.5. So basically, I think it's a little bit easier to visualize on this fraction picture up here, right? You have the middle, your actual median, and then what's to the left of that, you find the median of that section, and what's to the right of that, you find the median of that section. So you're finding the middle of the middle, which is why we go from halves to fourths. And fourths are quarters, which is why they call it quartiles. So it all kind of goes back to fractions in that language of quarters. All right, so then we're going to practice finding those quartiles. It says, look at set A. It says, when a set of data has an odd number of values, the median is a value in the set. What number is the median, or the middle number, of the set? So what's the middle number here? What are you going to see? Yeah, it's that middle one, okay? Because there's 1, 2, 3, 4, 5, 6, 7 data points, and the very middle one is that fourth one, which is 210. So our median is 210. Now, why is 133 the first quartile, and why is 275 the third quartile? Okay, because, actually, I'm not going to explain in words. I'm going to explain with a picture. Because the first quartile, these are the 3 numbers we are dealing with that are to the left of the median. And this is right here. This is the median, which is 133. Now down here, we've got, to the right of the median, 3 more data points. And the third quartile, this 275, is the median of that data. Okay, so it's always finding the median. It's like we found the median of the left half of the data, which is 133. And then we found the median of the right half of the data, which was 275. All right, so we have set B. When a set of data has an even number of values, the median is not a value in the set. So what that's saying is this first one was for an odd set of data. There are 7 data points. This one only has 6 data points. It's an even set of data. So for the odd set of data, it was a little bit easier because there was a middle number. It's very easy to go, oh, 2 10s in the middle, 133 is in the middle of the left, and 275 is in the middle of the right. But in this set of data for B, it's a little bit trickier because it's even numbers. So we need to find the median of the set of data. So that we know the median is right here. That line right here cuts this in half because we have 3 on the left and 3 on the right. So that cuts it right down the middle, which is our median. But what's the middle of 51 and 55? If you can figure that out in your head, go for it. If that's too tricky for you, then just do the math of 51. I guess I should write this where they tell me to write it. 51 plus 55 is 106, and then you take your sum, because we're finding the mean, and we divide it by 2, because there's 2 data points. So 106 divided by 2 is, I did not give myself space there, 106 divided by 2, and we get 53. And so 53 is our median right here. 53, even though it's not one of the data points, 53 is the median because it's the average of the 2 middle data points. Then it says y is 28, the first quartile, and y is 64, the third quartile. Well, again, I'm just going to kind of point here. 28 is because if the middle is right here, that means that to the left of that median, we have 3 data points, and the middle one is 28, okay? To the right of the median, for the second half of that quartile, right? So we're talking about this section to the right. The middle point of that is the middle number, which is 64. So 64 is the third quartile, okay? Now, it does not matter if these numbers are evenly spaced on a number line, okay? All they're asking for is what is your middle number, okay? If there's a tie for 2 middle numbers, then you have to find the actual mean, the very, very middle of them. Okay, next says, now we're gonna find the median, the first quartile, and the third quartile of the data on each dot plot. So now we get to do the same thing, but instead of looking at the numbers they gave us, we're gonna look at the data on the dot plot. Now these are not symmetrical. It's not the same on both sides in the shape, so we can't just draw a line down the middle to find the median. We're going to actually have to figure out what is the median by looking at our data. Now, for some kids, it's easier to list the data like this, so I'm going to do this first as a suggestion for kids that need it. So for some, it's easy to look at the dots and just write out all the numbers. So there's 1, 2, there's another 2, there's a 3, 4, a 5, another 5, 6, 7, 8, another 8, 9, 9, 9. There's no 10s, and then there's 2 11s. Okay, for some kids, it's easier to do medians if you have it all listed. Turn all those dots into a big list. And make sure when you do that, you do least to greatest, because when you're finding your median, your numbers have to be in order. That is a rule. So what would be the median here? Well, first we need to determine how many numbers that is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. there's 16 numbers, and the halfway point of 16 is 8. And 16 is even. So we don't just get to circle the middle number. We're going to have to figure out the mean of the two middle numbers, which is going to be between 8 and 9. So 1, 2, 3, 4, 5, 6, 7, 8. So right here is the middle point. We should have 8 on the left and 8 on the right, which we do. So what's the halfway point between 6 and 7? That one's not too bad to figure out. 6.5 or 6.5. Okay, so then what is the first quartile? Well, the first quartile is take your left half of your data, which is over here, and you want to find what is the middle point. So if there's 8 points here, that's even. I'm going to find the middle between the fourth and the fifth number. So 1, 2, 3, 4, right here. So here's the first quartile where this line is, because I split this data in half. There's 4 on the left and 4 on the right. And what is that point? Well, it's the average between 3 and 4, which is 3.5. Now let's look at the right half of the data, which is over here. Okay, if I circle all those, you can see what is the middle. 1, 2, 3, 4. There's the middle. 1, 2, 3, 4. What is the middle of 9 and 9? Just 9, exactly. And if you needed me to say, well, it's a tie between two numbers, Mrs. McPeak. Exactly. So you need to take your 9 plus your 9, which would be 18, divided by your 2 data points, which is 9. So that's why the median is just 9 there. All right, so now we're going to do that with plot B. Again, some kids can figure this out without listing all the numbers. Some kids are able to visualize how many dots there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so some kids go, oh, well, if there's 15 dots, I know that my 8th dot is going to be my median, because 7 plus 7 is 14, so the 8th dot is going to be that middle point. So some kids go like this: 1, 2, 3, 4, 5, 6, 7, 8. My 8th dot is right here at 58, and so 58 must be my median. But if that's too hard for you to visualize that, then just write all your numbers. It is totally okay to do that. But if you do it, I recommend doing it in a straight line. So 53, we have 55, another 55, we have 3 56s. We have 58, another 58, we have 2 60s, 3 61s, and I ran out of room. Bummer. Yeah, I'm not going to keep going. I like to do it in a straight line. The reason why I like to do it in a straight line is I think it's hard to find the middle if you do this and then you get cut off and have to do it on the next line. I think it gets confusing. So I'm going to give myself more space and try again. So I have 53, 55, 55, 3 56s, 2 58s, 60 and 60, 3 61s, a 62, and a 64. So that should be all 15 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Perfect. And so my middle point is going to be my 8th one. 1, 2, 3, 4, 5, 6, 7, 8. This is the very middle. Now I have 7 on the left of that and 7 on the right of that. Okay, so some kids, if they're just looking at the graph and they know that the 8th one right here is the median, then they say, well, how many's left? 1, 2, 3, 4, 5, 6, 7. And so they go, oh, well, that means that the 4th one must be my first quartile. 1, 2, 3, 4, which would be right here at 56. And then on the right side, 1, 2, 3, 4, 5, 6, 7. So there's 7 total on the right. The 4th one must be the third quartile, which again would be 61. Now, if that's too confusing for you to just look at the graph, I agree. I think that's a tricky strategy. If you can do it, great. It saves you the time to not have to write all these numbers down. But if you're like me and you're kind of a visual person, then go ahead and write all the data down, and then you can just do what we normally do. Here's our median, 58. So the left half of the data, where's the middle? Right here, which is 56. That's what we said for quartile 1. Here's our median. And then on the right half of the data, there's 7 data points, so the middle would be the 4th one, which is right here at 61. And that's what we put for quartile 3. So you just have to be mindful of what works best for your brain. Are you able to figure that out by looking at on the graph, or does it work better for you to write all the numbers out in order to figure out where your quartiles and median is? For me personally, I like to write it out. It's an extra step, but I make less mistakes that way. Okay, and our last page for this lesson. Puzzle Penguin. Dear math students, I can use mental math to calculate the range and the median of numbers at the right. The range is 60 because 70 minus 10 equals 60. And the median is 30 because 60 divided by 2 is 30. Is this correct? Your friend, Puzzled Penguin. Well, there's 2 things that he talked about. He talked about the range and he talked about the median. So let's start with the range. Is his range correct? He said the range is 60 because 70 minus 10 is 60. Well, I know the range is your greatest number. Take away your least number. So the greatest number is 70, and the least number is 10. And 70 minus 10 is 60. So I'm going to say his range is correct. Okay, for the second part, the median is 30 because 60 divided by 2 is 30. Is that correct? No, because he took the range for 60 and divided it by 2. That is not how you determine the median. So the median does not come from the range. So he found out the range was 60, and then he used that to find the median. But you do not use the range at all when you're calculating your median. So the median does not come from the range. The median is just your middle number. And in this case, what is the middle number? 40. So the median should be 40, not 30. Okay, Puzzle Penguin. So we're going to go to the next one. This is Dear Math Students. I was asked to calculate the first quartile of the set of data that's shown at the right. To calculate the first quartile, I divided the range by 4, like this. So I'm thinking he's thinking there's the quartile, you're making quarters, so he divided it by 4. So he took the range, divided it by 4, and then the first quartile was 10 minus 2, because that was the range, 10 minus 2, and then he divided that by 4. So the range was 10 minus 2, which was 8, and then he divided that into 4 parts, so the first quartile is 2. So he decided the first quartile is 2. Can you explain what I did wrong and explain how to correctly do it? Okay, so again, the quartiles do not come from the range. Okay, your range is your highest point minus your lowest point. The range is important. It determines how much variability or how much of a difference there was in all of your data points. If you remember back at the beginning of our lesson, we talked about Jayla versus Sophie. Jayla had a small range, little variability. It's predictable what she would do. Sophie had a large range. Her data was all over the place. It's hard to predict what she's going to do. So the range is an important data point, but it has nothing to do with the median, okay? And the median is what the quartiles are all about. So if we want to find the quartiles, he was asked to do the first quartile. That means first you need to find the median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 data points. So 1, 2, 3, 4, in between the 5th and 6th is where our median is. So in between 4 and 6 is 5, which is our median. Because 5 is the number that's the average or the mean of 4 and 6. And then we say Well, what is left of that? So right here, this is our line for our median, right in between 4 and 6, okay? So the left side of our data is all of these numbers, and because there's 5 of them, right here, the middle is 3. So the quartiles don't come from the range. We'll say the first quartile is 3. That's the answer he should have come up with, is 3. So they don't come from the range, they come from the medians. Okay, the median, the overall median, and then the median of your left data. And it didn't ask us for the right side, but I'm going to do it anyway. The median of our right side would be all these 5 numbers. What is the middle one that's there? Which would be 8. So 3 is quartile 1, 8 is quartile 3. And then 5 is the median that's right in the middle. Okay, so I hope that helps you guys understand a little bit about interpreting data using the median and the range and kind of the new idea of quartiles.